Okay, grade 7. Here is your book. We are doing what lesson is this? Lesson 2. And the lesson is on theoretical and experimental probability. Okay? Now, in theoretical is the one you just calculate without actually doing the experiment. You look and you make a decision, okay? In experimental, you spin. You actually do the spinning, okay? You do the spinning more than one time to see what answer you will get. So we will do a couple examples for you to understand. But as it is important, you need to understand what your vocabulary is. So in this lesson, our vocabulary is uniform probability, theoretical probability, and experimental probability. So a uniform probability model is a tool like a coin. A coin like your dirham is uniform because the faces are equal, so it is unbiased. When you're using a uniform probability model, we are saying use a uniformed or unbiased tool. So, like, why is this an unbiased tool? I want to look for a tool that is unbiased. Yes. Why is this container unbiased? Because the sizes are not the same. Do you see that? So I can't say it is uniform. This side is not as big as this side. Or this side, this face is not as small as this one. So I don't have uniform faces. That is why I'm calling it unbiased. If it has to be biased, so that is why I'm calling it unbiased. Oh, no. That is why I'm calling it biased and not unbiased. So this is not unbiased because it is not uniform. This is unbiased because it is uniform. The size of the head is the same as the side of the tails, okay? Now, when you have an unbiased model, you have like an unbiased coin or an unbiased cube. Everything must be equal. The sizes on your model must be equal, but you should have equal parts. Okay? One cannot be big and the other one small, like here. So on this spinner, this is unbiased because it is uniform, because each part is equal. You have 2 wins and you have 2 losses. Also, this green space is the same as the yellow space, which is also the same as the blue space and the same as the purple space. But when you come here, this is not equal. You have a small area of winning and a big area of losing. So this is biased, this is unbiased, okay? Biased because the parts are not the same, unbiased because the parts are the same. Okay, now, so uniform probability, each outcome has an equal chance of happening. So here you have an equal chance of happening because each part is equal. Here you don't have an equal chance of happening because not all the parts are the same size, okay? So that is how you explain uniform probability. Each outcome has an equal chance of happening. Now, theoretical probability comes when you have this. So you just look and say, how many chances do I have to win? 2 out of 4, which is 1/2. How many chances do I have to lose? 2 out of 4. So you must use a fair model or an unbiased model to do uniform probability, to do theoretical probability. So theoretical probability must come from uniform probability. When you're doing uniform probability, you must use an unbiased tool. An unbiased tool when you're doing theoretical probability. Now, experimental probability depends on relative frequency. That means how long did you do the experiment? So we are counting the frequency and the results that came out from your experiment. Okay? So these results will help us to determine the probability. You will see when we do an example. So, theoretical, what should happen? Experimental, what actually happened. Okay? This you do by calculating. This you do by doing the experiment. You must do the experiment. So, theoretical probability and experimental probability, sometimes they may be equal and sometimes they may not be equal. So it is sometimes they're equal, sometimes they're not equal. I drew this spinner because you need it for this example. So we are here. Example 1. I want to explain it clearly. So there was a spinner like this, and then you spun this black hand, and you counted, and you did it how many times? You did it 60 times according to the question. Says 3 equal parts. So I have 3 equal parts, and the colors are green, blue, and red. So I have green, blue, and red according to the work. So the graph, so I did this. I spun 1, 2, 3, 4, up to 60 times. And every time I spun, I recorded where this hand stopped. So on the green, it stopped where? At 21. 21 is for the green. And 15 is for the blue. And 24 is for the red. And I said I did it how many times? 60 times. So let's confirm this is 60. 1 plus 5 is 6. 6 plus 4 is 10. I carry this one. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 2 is 60. So there. So this is 60 times I did my experiment. Okay? Now, what did the question say? The graph indicates that the spinner landed on the red 21 times. So, what does the question want? Find the experimental probability of spinning red. So, how many reds did I get? 24. 24 out of what? So, I am doing experimental probability, and I'm doing for red. So probability for red will be 24 out of 60. And then you simplify this. The probability for green will be 21 out of 60. And then you simplify that. The probability for red will be blue. The probability for blue would be 15 out of 60. Now we simplify. What number goes in 24 and also goes in 60? I think 6. So divide this by 6, divide this by 6. I get 4 out of 10. So I can simplify this again. Divide this by 2, divide this by 2. I get 2 over 5. So this is the experimental probability for red. If the question asks me what is the experimental probability for green, I will do this. What number? 3. 3 goes in 60 and 3 goes in 21. So this is 7 over 20. And that's my answer as a fraction. What's the probability for experimental for blue? So I think 15 times something is this. So 15 times what? 60 divide 15. 4, yes. So divide by 15, divide by 15. That gives me 1 out of 4. So that's the experiment probability because I did 60 experiments. I spun my wheel I spun my hand on the wheel 3 times. 60 times, sorry, not 3 times, 60 times. And every time I spun, I recorded. So when after the 60th turn, I found out I had 21 green, 15 blue, and 24 red. And then this is what I got, okay? Now, let us do the experimental probability. This is the experimental probability. Let's do the theoretical probability for these colors. So the theoretical probability for red will be 1 out of 3. And for green will be 1 out of 3. And for blue will be 1 out of 3. Now, remember I say they can be the same or they cannot be the same. Okay? So, let's change 2 over 5 to decimal. 2 divide 5 SD, I got 0.4. And 1 over 3 to decimal should be 0.33. So these are almost closer. You see that? Almost closer. Let's do this one. 7 divide 20. 0.35. See? They are almost closer to 0.33. So this one is 0.33. See? They are almost closer. 0.35 is almost closer to 0.33. This is 0.25 and 0.33, like that. This is a little bit on the left side, okay? Because I got less reds. Less blues. You see that? The more you get, the closer you are to the theoretical. The less you get, the less you are from the theoretical value. So sometimes they can be the same, closer, or less than each other. Okay? So that's how you do experimental. On the experimental, the denominator is how many times you did the experiment. In the theoretical, it is how many parts you have. Okay? All right. Let us do example A. In A, it says refer to example 1. So that means go back up here. Yes? And now it says if the spinner was spun 3 more times. So we already did 60. So we need to do 3 more. So now we have 63. So my denominator will be 63. And each time it landed on green. So the number for green increased by 3. So what is 21 plus 3? 24. So there. So this is probability for green. It was 60. I added, wait, let me write. It was 60. We did 3 more experiments. So now we have 63 experiments. And every time I spun, I landed on green. So green increased by 3. So that was 24. Okay? The question is asking us, find the experimental probability. So we are doing the experimental probability. The experimental probability. I am answering example A. Probability. And then now you simplify this. So 24 divide 63. You get 6. So that means you can divide this by 4. You can divide that by 4. That gives you 6 over 20 over 21. Okay? And there. That's weird. $24 divided by 4 is 6. And 63 divided by 4 is 63 divided by 4. Why? What did I do? Anyway, wait. I need to know how I got 6 over 21. Wait. So 24 divided by 63. Oh, no, that's 8 over 21. Sorry. 8 over 21. You see why my math was not making sense? So 8, this means divide by 3. So 3 is the common factor. 24 divided 3 is 8. 63 divided 3 is 21. And there is my experimental probability when I did 3 more experiments. Now compare the experimental probability in exercise A. Compare the experimental probability in exercise A to the theoretical probability. So now we need to do theoretical. Theoretical. How do I spell theoretical? Yes, I spelled it correctly. Theoretical probability. So I said the answer for A, I need to compare with theoretical. How many green in my spinner? 1. 1 out of 3. So now I need to know the decimal for each. So I know this is 0.33. Now I need to do 8, change it to decimal, 0.38. And it is greater. So 0.38 is a little bit greater, just a little bit, yeah? So I can do this. See, they are closer to each other, almost closer to each other. They are not very, very far. All right, let's look at example 3. 2 number cubes are rolled together 20 times. So that means 20 is in your denominator. Now, a sum of 9 is rolled 8 times. What is the experimental probability for rolling a sum of 9? So, they are saying every time I get a 9, that means 5 plus 4 or 6 plus 3, like that. When they rolled, they got it 8 times. So what is the experimental probability? 8 over 20, which is 2 over 5. Okay? So the experimental probability of rolling a sum of 9 is 2 over 5. Now, can we do the theoretical? Let's do theoretical. So I have 1, 2, 3, 4, 5, 6. Now to make a 9, I need a 3 here. To make a 9, I need a 4 here. I need a 5 here. I need a 6 here. To make a 9, I need a 7, so I don't have a 7 on my cube. So this is impossible, okay? So, how many numbers do I have? I have 12. Yes, I have 12. Sorry. So this is 1 outcome, 2 outcome, 3 outcome, 4 outcome. Okay. So the probability of roll, so then since this is, so this will be 6 times 6 because I'm doing 2 of them. Not 6 plus 6, 6 times 6 because I did 2 of them. And then I got 1, 2, 3, 4 there. So then I got 4 out of 36, which is equal to 1 over 9. So this is the theoretical. Okay? So when you're comparing the experiment, so now you have 2 over 5 and you have 1 over 9. You see, when rolling 2 number cubes, there are 36 possible outcomes. Okay? There are 36 possible outcomes when you're rolling 2 number cubes. So let's show the 36 possible outcomes. You can get a 1, a 2, a 3, a 4, a 5, a 6. And here you can get a 2, a 3, a 4, a 5, and a 6. So here you get 3, 4, 5, 6, 1, 4, 5, 6, 1, 2. Here you get 5, 4, 6, 1. Am I missing? Yes. Yes. No. 4, 5, 6, 3, 5, 6, sorry, 5, 6, 1, 2, and then 3. And then here you will get 6, 3, after 6, it's not 3, it's 1. 6, 1, 2, 3, 4. And then here you will get 5. No, 6 is 1, 2, 3, 4, 5. How many do you have all together? You have 36. So that is why here is 36. Because you're rolling 2 of them at the same time. So you have 36 chances or 36 outcomes. So then you make sure you simplify. Okay? How did I know? Because I know it is a square. Because it's 2 of them, I knew I had to multiply 6 by 6. But you should know how I came up with the 36. So 1 out of 9. And there is your answer. This is your answer for theoretical. Theoretical probability. And this is your answer for experimental probability. Where is it? Here. Here is your answer for experimental probability. Because they say 20 times, you do 8 out of 20. All I did is explain these ones. Okay? And here is your table. So you see what I did? Look. When I want to get a 9, I need a 3 and a 6, 4 and a 5, 5 and 4, and 6 and 3. And that's exactly what is there. Okay? Now let us do for letter C. In example 3, what is the experimental probability of a sum that is not 9? Not 9 will be you minus this from 1. So you will do 1 minus 1 over 9, and you should get 8 over 9. Remember that. When you're doing for not, you minus it from 1, or you minus it from 100%, if the question gave you a percent. Remember, that's the complement. Keyword there. You subtract from 100, or you subtract from 1. So because we have a fraction, we'll subtract from 1. If we had a percent, we'll subtract from 100%. So please do D and E. Do D and E, and then do guided practice. We'll talk about 5 tomorrow. Or you can look at it. Yes, look at it, and if you have any more questions about 5, you'll ask me tomorrow. But do examples 1, 2, and 3. I mean question 1, 2, and 3 of guided practice. And then we'll see each other tomorrow. Make sure you also do, what is it called? Aleph.